Hi, my name is Victoria Contreras, and this is my own personal physics lab adventure. So what personal adventure did I choose? It's simple enough. I chose a recording of a person falling at the same time as another object, which I chose as a water bottle. Now that may seem extremely simple, but I have my reasons. My question since the beginning of physics is, why did the fact that mass times gravity was hard to think of whenever I saw, say, a bowling ball and a ping pong ball drop simultaneously. Why did I always want to say that the bowling ball hit the ground first? And still now, my intuition when I says a person versus a water bottle drops, why does that occur? So with my physics, knowing that mass times gravity, or rather mass times velocity, and your velocity here is going to be your gravity, is what's going to do our momentum. That's through the momentum principle. Then my prediction through physics is going to say that the items reach the ground at the same time. However, what I want to say is that the person, of course, because they're heavier, is going to reach the ground first. So let's see the stats of what we have here. We have the mass 68 kilograms and the length about 2 meters of our person. And then we have about 1 kilogram for the bottle and 0.04 meters for the water bottle. So let me show you my tracker video. As you can see, I'm tracking the two center masses. As you can see here, the center of mass is a tad behind, lagging compared to the water bottles. And of course, his center of mass never reaches the ground because he never reaches that. So that goes against the laws of physics, of course. Why is that? Let's go ahead and take a look at our lab, or my model I created. So my model here is of the momentum principle. I use velocity and net force in order to calculate this model of having two objects of different masses dropping due to the force of gravity. And as you can see here, they have the exact same data. They drop at the same speed when dropped from the same height. So when we compare that data from the tracker, this is what we get. These two bottom graphs are from the tracker. As you can see, there's slight discrepancies. They're relatively the same, but there are still discrepancies. Whereas this top yellow line is from the model. Now, this of course doesn't make sense because our model does not correlate with our real life data. So why is this? So, as I was saying earlier, the center matches hit at the same time, or relatively the same time, but the discrepancy could be because of the height at the beginning, as we see his feet hit the ground. And the physics that we're having to take into account is our momentum principles of mass times velocity and the net force times time. So obviously we have here our force is our gravity, bringing down our mass of our bottle and of our person. So why the misinterpretation? Why the thought that they're being dragged at different velocities down? So from this experiment, I had two conclusions. One, the net force wasn't being calculated correctly. You can't really calculate correct momentum principle without a net of the forces. As you saw, I was calculating just the gravity force, but actually drag has to be accounted for as well. That would include drag constant and physics capabilities beyond physics 1 for me right now anyway, but that's definitely interesting. And other factors, of course, just say that there's initial velocity of the person pushing off of the building or off of wherever they're jumping from, or the height of the individual, of their feet hitting the ground before their center of mass does. So, and that, of course, altering their center of mass because they're going to be moving and turning and perhaps creating angular momentum, spinning. this lab has brought to my attention the complexity of a person falling versus a water bottle falling. So yeah, that was my adventure, and now I definitely understand why, in a simplistic way, the mass times gravity does have a person and another object dropping at the same time. However, we may see something differently because there are other factors that come into play. So thank you very much.